Hello everyone, I am Dr. Godandaraman. In this section, Lagranges linear equation, the second method of multiplier problem we are going to discuss. Solve, the problem is nothing but x into y minus z into p plus y into z minus x into q equal to z into x minus y. Before that, to check the given problem, what is the form? The form is nothing but linear form, linear Lagranges form, capital P, small p, capital Q, small q, and then R. When this form, then you should write the auxiliary equation. What is the auxiliary equation? Dx by capital P, dy by capital Q, dz by capital R. Then they compare this given problem. The small p near whatever the value is there, it's a capital P. Therefore, capital P is equal to x into y minus z, capital Q y into z minus x, and then capital R z into x minus y. Now I'm going to substitute in this value for the auxiliary equation. Dx divided by x into y minus z and dy divided by y into z minus x, dz divided by z into x minus y. In this equation, I am going to apply with the multiplier. Our main aim, the denominator if 0, then easy for numerator values. So in these cases, if you want to add any value, we consider multiplier. Any variable, any constant, whatever we are applying in this term, 3 term, we just do it. Now what is my plan? Now I am going to add all the 3. Once I adding all the 3, it should become a denominator value possible to get 0. Therefore, now I am going to take dx plus dy plus dz whole divided by x into y minus z plus y into z minus x and plus z into x minus y. I just going to take this all the 3 to adding all the 3. When I'm doing like this, dx plus dy plus dz whole divided by xy minus xz plus yz minus xy plus xz minus yz. Now I'm going to check here any common term. Actually the common xy cancel, xz cancel, yz cancel. Therefore we have the value, this term dx plus dy plus dz equal to 0. Now I'm taking integration of dx, integration of dy, integration of dz equal to some 0 value. And whenever you are looking here, sir, 1 by 0 infinity, then how you are writing the value 0? It's a meaning. Now I mentioned that we are going to take some constant. Is it clear? When introduction class I mentioned that the k is some constant. Therefore the k into 0, the whole term 0, this is only the reason I am going to take this dx plus dy plus dz equal to 0. Then direct integration of this value, dx integration x y z, now one constant. The constant is nothing but u equal to a, then u equal to x plus y plus z. This is a one solution of the differential equation. Now we consider another multiplier. One multiplier we have directly integrating and getting the solution. Again another multiplier we are going to consider. When I am going to look this, I am just directly adding this equation, so automatically the denominator will be 0. Now I am just looking here, better I am taking another multiplier, 1 by x, 1 by y, 1 by z. It will be become denominator possible for getting 0. Therefore this term dx by x into y minus z and dy y into z minus x and dz z into x minus y in this term I just do it here. 1 by x dx plus 1 by y dy plus 1 by z dz. It's a meaning the numerator and denominator are multiplying for here 1 by x dx, 1 by x dy. Therefore this term x, I think numerator 1 by x, then denominator 1 by x. When I'm doing like this, x will be removed. It's meaning x by x, y minus z plus y by y, z minus x plus z by z, x minus y. Now the denominator value, I think this x will be cancelled. X term cancel, y term cancel, z term cancel. Therefore dx by x, dy by y, dz by z whole divided by y minus z, z minus x, x minus y. Now when I'm checking this, y, x, z cancel. Therefore dx by x plus dy by y plus dz by z equal to 0. For this form, again direct integration dx by x plus integration dy by y integration dz by z equal to 0. Integration of dx by x is nothing but log x, log y, log z equal to some constant I consider log b or only b or c, whatever, but simplification purposely I am taking log b, log of a plus log of b plus log of z. So c equal to log of x, y, z and log of b. Now I am going to take this x, y, z equal to b. So v equal to b, v equal to x, y, z. Finally, the general solution of the given linear equation, pi of uv equal to 0. Therefore pi of u value, u is nothing but x, y, z, then x, y, z equal to 0. So this is one of the problem using method of multiplier. Now we are going to solve one more problem. Look at here. Solve mz minus ny into p, nx minus lzq equal to ly minus mx. In this problem, as usual, the form to check, the form capital P small p, capital Q small q, or this is the linear partial differential equation form. Then the auxiliary equation dx by p, dy by q, dz by r. Now what is the p value? Just look at the given problem. P is whatever the value near small p, all the values are capital P. Therefore mz minus ny, capital Q nx minus lz, and capital R ly minus mx. These are the capital P, Q, R value. So capital P mz minus ny dy divided by nx minus lz and dz divided by ly minus mx. Now I mentioned that you consider the multiplier any values, constant or variable, whatever you just consider. Whenever I am looking the problem, so what value is possible, because our main aim is if I am going to add all the three terms, the denominator becomes 0, then easy for integration numerator. So now our aim is to just look at this problem. Our main aim is the denominator how to convert 0. So now in this problem I try to multiply. I just consider some of the multiplier value. So maybe the multiplier, how to solve this multiplier? I am going to using the multiplier L M N. So we get the ratio is equal to, for example, L dx m dy n dz divided by L into mz minus ny plus m into nx minus lz plus n into ly minus mx. So I multiply numerator denominator for the first term L and the second term m and the third term n. Now when I expand the denominator value, if 0, then the numerator also 0. When if denominator 0, then numerator also 0. L m z L n y m n x m l z m l y, sorry, this is a n l y minus m n x. To check this, L m z, these two cancel, and then L n y, these two cancel, and then m n x, these two cancel. Therefore L dx m dy n dz equal to 0. Direct to integration. So integration, we get the value, integrating L dx m dy n dz equal to 0. Now L x m y and then n z, one constant, u equal to a, then u equal to lx my n z. Then consider another multiplier. One multiplier we have considered. Based on that we have one solution. Again to consider another multiplier. The another multiplier nothing but using the multiplier x y z. Now the term is nothing but ratio is equal to x dx y dy z dz whole divided by x into mz minus ny plus y into nx minus lz plus z into ly minus mx. This is the above ratio term. Now the denominator x dx y dy z dz whole divided by, just multiply inside the value, x m z x n y y n x y l z z l y z m x. So now I am going to check with any term cancel, minus x n y plus x n y, and then x m z and then yl z yl z. So denominator is cancel, therefore x dx y dy z dz equal to 0. Now integrating, we get the value. So integrating x dx y dy z dz equal to 0. X integration, x square by 2 y square by 2 z square by 2 equal to the constant b. Simplification purpose I am going to take b by 2, or you take b only, it's no issue. Now x square y square z square equal to b, v equal to b, v equal to x square y square z square. Now the general solution is nothing but pi of uv0. The pi of u is nothing but lx my n z, then v x square y square z square equal to 0. The order is not a issue. Shall I consider the multiplier first x y z, next to l m n, then okay, fine. So whatever order, not a issue. Okay, so this is a method of multiplier. Thank you.